Today, we will discuss RC circuits. RC circuits are simply circuits that have a capacitor and a resistor. The circuit may or may not have a battery. If it does have a battery, then the capacitor is usually being charged. If it does not have a battery, the capacitor is usually being discharged. When charging a capacitor, the amount of charge between the plates, as well as the voltage across the capacitor, will approach the voltage of the battery with time. The amount of charge follows a curve defined by this equation, where big Q is the maximum charge and little q is the instantaneous charge at time t. When discharging a capacitor, the voltage across the plates approach zero with time. Here we use this equation, where again, big Q is the maximum charge and little q is the instantaneous charge at time t. These equations have a term RC, which is the resistance times the capacitance. We call this the time constant, and sometimes abbreviate it to the Greek letter tau. In our first example, we have a 1500 ohm resistor and a 25 microfarad capacitor. The capacitor has been charged to a voltage of 35 volts. We would like to know how long it will take for the voltage to drop to 15 when the switch is closed. The capacitor will discharge across the resistor, so we will use our equation for discharging capacitors. We have voltages given instead of charges. So, because the charge across the capacitor is equivalent to the capacitance times the voltage across the capacitor, we can make a few substitutions. We move the exponential term by itself to one side of the equation. Then, we can take the natural log of both sides of the equation to eliminate the exponential, and rearrange to solve for t. Plugging in our numbers and solving, we have a final answer of 3.2 times 10 to the minus 2 seconds. In our second example, we have a 1500 microfarad capacitor charged through a 25,000 ohm resistor by a 12 volt battery. We would like to know how long it takes for the battery to charge the capacitor to 8 volts. Here, we are charging a capacitor using a battery, so we would like to use the equation for charging a capacitor. Again, we have voltages, so we change the charge term to be in terms of voltages. We continue to rearrange the equation with the goal of getting the exponential by itself on one side of the equal sign. Again, we take the natural log of both sides to get t by itself. Plugging in the numbers that we know, the resistance, capacitance, and relevant voltages, we have a time of 41 seconds.